Given question, stress is limited to 130 meganewton per meter square for the middle portion. Find the length of the middle portion if the total elongation of the bar is 0.15 millimeter. Take E is equal to 100 giganewton per meter square.
Let us understand given question. This is the bar of different diameters and the total length of the bar is given 250 millimeter. We have to find out the length of this middle portion of the bar so that total elongation of this bar is equal to 0.15 millimeter. If we observe, tensile force is applied and it is equal to 50 kilonewton. So how to find out the middle length of this bar? So we will consider the middle portion length is equal to x and the condition is given that total elongation of this bar is equal to 0.15 millimeter. We will give the suffix 1 to this middle portion. So I will show here the suffix 1 to the middle portion which is having diameter 22 millimeter. And suffix 2 for this end portion which is having diameter 40 millimeter. Now it is the bar with different diameters. So there are two different diameters. So there are two suffix 1 and suffix 2. Now total elongation of the bar is equal to elongation of this middle portion plus elongation of this end portion. So we can say that delta L is equal to delta L1 plus delta L2. So we have to find out this delta L1 and delta L2. And for that we have to first find out the value of stress in this middle portion as well as end portion, that is sigma 1 and sigma 2. So we have formula to find out stress. So we know that stress is equal to P, that is applied force divided by cross-sectional area. So cross-sectional area, this bar is given with circular cross-section. So here for this circular cross-section we have to take area is equal to pi by 4 diameter square. So we will apply this formula to calculate sigma 1 and sigma 2. So in case of sigma 1 we will take 50 kilonewton, standard unit is Newton. So 50 into 10 raised to 3 divided by area of this middle portion, that is A1, pi by 4 0.022 square. So we have to use standard units. So it is equal to 131.5 mega Newton per meter square. So answer is in Newton per meter square in calculator and we have to convert into mega Newton per meter square. So answer is equal to, in calculator if we observe, it is 131.5 into 10 raised to 6 Newton per meter square. So we have to convert this into mega Newton per meter square. Now in case of sigma 2 we have to take diameter is equal to 0.040 meter and we have to calculate this. So it is equal to 39.78 into 10 raised to 6 Newton per meter square. So in short we will write 39.78 mega Newton per meter square. Now these two values sigma 1 and sigma 2 are important to calculate elongation in this middle portion as a delta L1 and elongation in the end portion as a delta L2. How to calculate elongation in middle portion and elongation in the end portion? That is, to find out the value of delta L1 and delta L2, we have given Young's modulus E is equal to 100 giganewton per meter square. So standard unit is Newton per meter square. So we can write 100 into 10 raised to 9 Newton per meter square. So we will put these values. So E is equal to, so we have formula with stress by strain, and strain is equal to change in length by original length, that is delta L by L. So we will write E is equal to sigma divided by delta L by L. We will simplify this sigma L by delta L. Now we have to find out the formula for delta L. So delta L is equal to sigma L by E. Now we have two suffix, that is suffix 1 and suffix 2. So we have to write the value for this middle portion as a delta L1 is equal to. Now for this middle portion which is having diameter 22 millimeter, we have to write sigma 1 and then L1 divided by E. And for this suffix 2 which is for the portion having diameter 40 millimeter, we have to write delta L2 is equal to sigma 2 L2 by E. Now what is the value of L1 and L2? So L1 is the length of the portion having diameter 22 millimeter. So it is L1 is equal to x meter. So we will give unit is meter, standard unit is meter. Now what is the value of L2? So it is the length of the portion of this bath having diameter 40 millimeter. So how to find out this? So if we observe this diagram, here is 250 millimeter, that is 0.25 meter. So I will write L2 is equal to 0.25 minus x. So its a unit is meter because standard unit is meter. So we have to take this value of L1 and L2 in meter. Now we will put this value and we will write the equation. So we have equation delta L is equal to delta L1 plus delta L2. So put the values sigma 1 L1 by E, sigma 2 L2 by E, and then we will get the equation in terms of x. So delta L is mentioned in the question. Total elongation is equal to 15 millimeter, 0.15 millimeter, that is 0.15 into 10 raised to minus 3 meter. So if we solve this, we will get the value of x. If we observe here the value of sigma 1 and sigma 2 in mega Newton per meter square. So we have to convert it into Newton per meter square by multiplying with 10 raised to 6. So if we transfer this denominator term to the right hand side, then it will become 15 into 10 raised to 6, and for this right hand side here also 10 raised to 6 is the common term. So we will cancel this, and then it is easy to simplify this, and value of x is equal to 0.055 meter because x we have considered is in meter. So we will convert it into millimeter. X is equal to 55 millimeter.